Hello, in this short video we are going to investigate the following challenging problem on the topic of evaluating definite integrals. Consider the following integral as you see on the display now. The value of this integral is equal to. Pause the video at this point and give it a try to see which one of the given options is the correct answer to this problem. Okay, to solve this problem, I want to use this famous theorem about definite integrals. If you have a function f which is integrable in the interval from a to b, then we know that integral of f of x dx is equal to integral from a to b f of a plus b minus x. This is a very famous theorem in definite integrals. So I don't want to prove it again here for you. I want just to use this to find the integral. Okay, but before doing that, I want to do some minor simplifications by a very simple change of variable. So what I will do, I will call x squared to be capital X. Then I differentiate both sides, so it becomes 2x dx. On the right hand side I will have d of capital X. Then I divide everything by 2, then I will have x dx equals to 1/2 d capital X. And the reason I did that because this x dx now can be written as 1/2 capital Dx. But of course, when I do a change of variable in a definite integral, this will cause a change in the limits as well. So that's also very easy. We know that the little x, according to the problem, goes from square root of ln of 2 to a square root of ln of 3. So this would then imply that capital X, which is little x squared, goes from ln of 2 to ln of 3. Okay, so if you don't mind, let me call my integral I. My goal is to calculate I. So let us imply this change of variable first. So integral I can be written as integral, instead of going from square root of ln of 2 to a square root of ln of 3, I go from ln of 2 now to ln of 3 because now my variable is capital X rather than little x. And what happens now? Instead of x times dx, I can just simply put 1/2 d capital X. 1/2 is a multiplicative constant, so I can pull it out from my integral and I put 1/2 here. And then it becomes sine of x squared, but x squared, little x squared is capital X. X dx, I can just write dx, 1/2 is already pulled out, divided by sine x squared becomes sine capital X plus sine ln of 6 minus capital X. Okay, so this is what I have. This is the new form of my integral. And if you don't mind, for simplicity, let me write dx exactly in front of my fraction. Of course, it doesn't matter that much. So let me write d capital X here. Okay, now I want to use this formula that I mentioned from the beginning. So if this integral is I, integral I can also be written as 1/2. So you see now I want to give the role of f of capital X to this function. So what I have to do, I have to calculate f of a plus b minus x, but a and b are the limits of integration, which are ln of 2 and ln of 3. Okay, so I can also be written as integral from ln of 2 to ln of 3, but sine, instead of capital X, I write a plus b minus capital X, where a is ln of 2, b is ln of 3. So this becomes sine of a ln of 2 plus b ln of 3 minus capital X, divided by the same thing for the first part. So I just do it quickly. And then plus sine of ln of 6 minus ln of 2 plus ln of 3 minus capital X. This is what I have. And then I have dx. But now I can do some simplifications because we know that ln of 2 plus ln of 3 can be written as ln of 6. This can also be written as ln of 6. So this can also be written as ln of 6, but the good news is that this minus sign makes this minus ln of 6. ln of 6 and ln of 6 are cancelled. Minus minus becomes plus. So if you don't mind, let me write it in a little bit simpler way. So this becomes 1/2 integral of ln of 2 up to ln of 3 sine of ln of 6 minus x all over sine of ln of 6 minus x plus sine of ln of x. Sorry, so sine of x. Yes, and dx. Okay, so let me just review what we did. First, I did this change a variable. I changed my integral into a little bit simpler form. Then I used this famous theorem on the topic of definite integrals and also showed to you that the integral I can also be viewed in this form. Okay, now it is very simple now to understand what to do. Look, if this is I, this is also I. So I add I to I, so it becomes 2I. But why this is good? Because first of all, when I am adding I to I have a 1/2 here, I have a 1/2 here, so I can factor 1/2 out. Then what happens? This becomes this integral plus this integral. But because of the properties of definite integrals, I can combine these two integrals into one integral on the condition that I add the integrands. So what I will do, this becomes integral from ln of 2 to ln of 3. Yes, and then I will have sine x over sine x plus sine ln of 6 minus x plus the other integrand is sine of ln of 6 minus capital X divided by sine of ln of 6 minus capital X plus sine x, and everything multiplied by dx. Okay, now I have to take this one. I do not have enough space here. I will take the last row to the next page. Okay, so this is what we have. But now what is good here, you see that the denominator here of this first fraction and the denominator here of the second fraction are exactly the same. So this means that what I can do, I copy and paste 2i, I copy and paste 1/2 integral from ln of 2 to ln of 3. Then what happens, I add the numerators with the same common denominator. So this becomes sine x plus sine of ln of 6 minus x all over sine x plus sine ln of 6 minus x. And then I have dx. But now what happens, this expression and that expression are exactly the same, so they are cancelled, so I will get 1. So if I repeat this once more, 2i becomes 1/2 ln of ln of 2 to ln of 3. My integrand becomes simply 1 dx, but this is extremely easy to calculate because this becomes 1/2. A primitive function for 1 is just capital X. I have to run it from ln of 2 to ln of 3. So this becomes 1/2 ln of 3 minus 1/2 ln of 2. I can factor a 1/2 out, so this becomes ln of 3 minus ln of 2. So this becomes 1/2 ln of 3/2. But be careful, this is not I, this is 2i. So in order to find I have to divide everything by 2. So I becomes 1/4 ln of 3 over 2. So that is the answer to this problem. Okay, so now let us see which option is correct. So as you see, option B is the correct answer to this problem. I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.